Hello, Chemistry 10H students. This is Mrs. Altman, and this is the second part of the videos on electron configurations. We'll be talking about shorthand in this video. So all shorthand is we represent only the valence electrons. So in this case, I have the electron configuration for sodium up both ways. So on the left, I have it written in its longhand formation, and on the right, I have it written in the shorthand. So for the shorthand, you show the core electrons by representing them as a noble gas. So before we actually get to the examples, it would help if we just had a little list of how many electrons each noble gas has. So helium has 2, Ne has 10, argon has 18, krypton has 36, Xe has 54, that you're not really going to need to do too many with that. And same thing, radon, you're not going to need to do too much with it, but it's got 86. So that's going to help for you to know which one you're going to. And there's two different ways to approach these. All right. So I'm going to walk through these. I'm going to walk through sample problem E the first way I like to do these, and then sample problem F the other way that I like to do these. So the first thing that you're going to do is you're going to find this on the periodic table, and you see that it is number 43. When I look at TC on the periodic table, I just go up a row and I see that the noble gas that is before it is Kr. And then I just go and I see that I'm in the fifth row. So 5s squared, or not squared, just 2, 4d, and then 5 because it's the fifth one in. You could also write the longhand configuration and replace the first 36 electrons with krypton. That's what I'm going to do for sample problem F, but I'm going to show it the short way here. All right, next I've got calcium. So calcium I find on the periodic table, it has 20 electrons. I see that it is in the fourth row. So that means I'm going to start with argon because argon's the third noble gas. And then it's just 4s2. So then calcium with a 2 plus charge, it's just 20 minus 2, which is 18. So I do allow students to write it as AR, but that's actually not considered to be the best way to show it by most chemists. So I'm also going to show you the other way that I like to do it. But again, I accept both answers for the H class. For like AP, I don't, but just to give you an idea of what you might see elsewhere. So you could also do neon 3s2, 3p6. The reason why the second way is better is because I can look at it and just see that it has 8 valence electrons as opposed to having to put a little bit more thought into it. And then for iodine, it is number 53. I go up a row and I see that the noble gas that is up one row is krypton. And then I go to the row that iodine is in, which is the fifth row. And then it's the fifth one in. I'm going to now do sample problem F, but I'm going to do sample problem F a different way. I'm going to do it a way that a lot of students like to do it. So I'm going to do this where I actually show the longhand first, and then I shorten it. So this is actually not my preferred method, but since I know a lot of students use it, I'm going to show it this way. So once you have the longhand version, you just find the noble gas, and in this case, it has to be helium, since I don't have more than 10 electrons. So magnesium has 12 minus 2, 10 electrons. So for this, you could replace the 1s2 with helium, and that would probably be the best way to do that. Although I wouldn't take off points if you were to just write it as neon. Phosphorus, this has 15 electrons. So then when I rewrite it, kind of like a sort of trick if you're doing it this way, noble gases all end with P6 aside from helium, which is just 1s2. So 2p, it's the second row, so Ne. And then gallium, this has 32. So then when I rewrite it, I find again the P6 in here, which is 3p6. So that means that I'm going to replace that with argon. And then just by looking, I can tell that this has 13 valence electrons. All right, appreciate you taking the time to watch this. Have a great night.